Hey everybody, Rich here with the answer to this week's puzzle. I chose a puzzle which illustrates the danger of floating point calculations and leading to possible unpredictable outcomes. I made the problem specific to Java for two reasons. The first being I just needed to decrease the scope. The second reason was that there's so many back-end systems out there, and banks, insurance companies, and other major enterprises that are using Java primarily for their back-end. As a result, you're going to see a lot of questions and interview questions based on this type of a pattern. This is one of the more interesting problems that I've encountered, and it's very simple.
This puzzle asks the question, which variable is not equal to itself? Java's implemented the IEEE 754 floating point standard. This standard reserves a special value to represent a quantity that's not actually a number, referred to as NaN, not a number. NaN is the value of floating point numbers which don't have well-defined values. An example of this would be 0.0 divided by 0.0, which if you remember your calculus can be kind of a problem. This specification states that any NaN is not equal to any other floating point value, or any other value, including itself. So let's go into some of the actual work here. I've set up the problem as I posted it. Now what I'm going to do is I'm going to put in a failure print line. Just for the demonstration purposes, you don't have to do this. And I'm going to add a counter so that if we actually hit the infinite loop, you'll see all of the print lines. And the first thing I'm going to do is I'm going to write a failure scenario just so we can all see it fail. 5 is equal to 5. This will return false, and the failure print statement will occur. Very good. Next, what I'm going to do is I'm going to actually come up and create an NaN. So let's do it. I'll run the program. And what you'll see is an infinite loop. See all the whiles. There's also a reference in Java, float.nan. Makes it a little easier. Run it again. There's two more that I could think of off the top of my head. Double. Remember that double is cast by default. It doesn't really matter. One final. Now the question is, what about this one? I just did 0.0 over 0.0, so why doesn't this cause a failure? And the answer is IEEE 754 is a floating point specification. Int is not a floating point. It's stored differently in memory. So what I'm going to do is I'm going to throw a try-catch around here and just show you what happens. And let's run it one last time, and I'll show you what will happen. This will fail, throw an exception, get caught here, and print this. As you can see, exception occurred. Divide by 0. If I go to the line, this is the line that caused the exception. Well, there you have it.
If you read the Java specification, what you're going to see is that any equality or comparison operator against an NaN floating point variable is going to return false all the time. And the not equal is going to return true. The lesson you need to take away from this is that you need to be careful with floating point comparisons in your if conditional statements as well as your while conditional statements. We had a lot of interest in this particular puzzle. I urge you to try. I'm going to post another puzzle next week, so please invite your friends to friend me on Facebook, and I will be posting another puzzle within the week. So as long as there's a lot of interest, let's keep going with this. Congratulations, Christian Kleinert. You won the first. You were the first person to give me the right answer for puzzle 1. So I will be sending my check in the mail. Until next week, be good.